Yes, hello, this is Sean Boyke coming to you from California. I'm here to present an exciting new material, a brand new material that never existed before on Earth. It's actually the first and only solar microwave fabric. Now what that is, that's actually a structural fabric that is custom sewn to whatever type of need that you may have, whether it's bulletproofing, whether it's making space satellites, whether it's to make tarps for electric boats or tarps for a boat or RVs, electric RVs. Now, not only does it create the energy, but it also will transmit the energy. So, and it works as with microwaves, we can actually do communications with it. So it is its own grid. That's why we called it and nicknamed it Insta-Grid. Now to full now to fully understand the Insta-Grid, first, we custom sew the fabric, the composite hybrid fabric. It might be sewn with maybe some electronic grid system into it, which would be conductive fabrics into it or wires into it. And then we put a substrate layer on it. Then we print or we add 3D printing or additional manufacturing. We add the solar cells to it and patch antennas. Then we may add some type of clear or environmental protection in it. As you see in the middle of the slide here, that's a finger on top of the material itself. You can see it comes out in rolls. We can custom make and design the rolls or fabric into any shape and form we might need it to be. So to give you a good understanding overview, the three main parts of that Insta-Grid is actually the custom sewn fabric. We've chosen the only machine in the world that can do three-dimensional sewing. It can actually do pockets, sleeves, gloves, all in one machine on one pass because they reinvented the sewing needle heads to it. So Shima Seiki is the best one known to mankind. They actually have a design system for that, so we can custom do that. We do some top secret programs with this for composites. Then we have the printed solar cells, which technologically it started at 1 or 2 from MIT. Now we're gone up to 14% efficient, which is fantastic. Back in the 80s, 90s, they only had like 11. 6% was common. 11 was really high. The best that is known is that is 45, 46% from German, even though Elon Musk and his Solar City, they brag about their, 23%? Whoop-de-doo! That is not the best. Anyway, we add that, and then we also add the patch antennas. Being that we come from aerospace, we do patch antennas, and we print those on top of it and put that into the entire integral fabric itself. So that's this in one slide. That in a nutshell. It's important to point out the R&D leadership, and David Hyland invented this. I met him in 2013. We were co-moderators at the International Aerospace and Engineering Conference in 2013, and I told him about space-based solar power, that I had worked on some programs doing that, and I sent him all the slides and all the reports. He came up with the solar microwave fabric and then a new way to do it for satellites, space satellites. So he invented it. Then I met 6 months later, I met Dr. Paul Werbos, who knows all about space solar power almost from ground zero, but actually Peter Glaser is the one that did it, and 50 years ago. This is his 50th anniversary this year of the invention of it. So these are key leaders, and this is how we will get through the R&D, that and our network of experts. You're only as good and successful as your team, and these are just some of the key leaders. We actually have 111 people pointed out, but some of the key leaders here are to make us very successful at the beginning of this company. Everyone here has been successful on more than a couple dozen programs, very huge ones. We are developing the proof of concept, which is actually taking the theories that I've spoken to you of and bring them into reality by proving such. We will actually, this is cool, we'll have the material outside and inside a dark room at a distance away. We will actually take the energy of the sun, take the DC power, convert it, transmit it, and transmit it at 2.4 to 5.8 gigahertz, the same thing that you use on your cordless phone, but with energy, and we would transmit it to an inside room where we'll illuminate a dark room and proving that we can do this safely and wirelessly. That's just the beginning. Since we are really interested in using structurally useful and applied materials for the solar cell, unlike what you have today, which is just some big old square box that you put up on top of a roof. Looks ugly as heck. This stuff can be super thin as mylar or Kapton, which is what you print electronics on, or it could be made out of Dyneema, carbon fiber. Um, Dyneema is bulletproof. You have different Kevlars. Anyway, whatever the application is, we will custom sew it. And this is a Shimaseki machine, which can do three-dimensional sewing. It can actually do an entire suit in one pass on one machine. It's actually revolutionary. So we will be doing this, and then you can actually pick which fibers go in at what orientation. So we can put conductive fibers in as we sew. Three-dimensional fabric with sewing and a circuit board woven into it. Pretty darn cool. Solar cells, or best photovoltaic. Looking at this chart, which is a great chart created by the National Renewable Energy Lab, which is a part of our Department of Energy in the United States, many universities and many countries want to get onto this chart. That means that you've done something very substantial and you're progressing into the new renewables of the future. There are many different types of renewable solar cells here. We are going to take the most emerging ones. Of course, we want to go with a thin film type or a printable, 3D printable, and maybe an electronic dye type. So only less than 7 years ago, MIT had the world record type, and that was only at the 1-2%, below 4%. Now we're up to 14%. And there's others that are looking really good with the perovskite, which is up at the 22, 23. Everything is getting better and better all the time. So we are going to take the emerging and improve on that and use it to our application. This is a solar cell printing machine, which is done over in the Pacific Islands. You can see how it's all integrated as one simple functioning automated machine. We will do as automated as humanly possible. The more we have it automated with quality inspection built into it, turnkey, and synergistically working, then we can get rid of the errors and really mass produce it and lower the cost. Another roll to roll, we call this a roll to roll process, and this is how we will actually do the printing of our solar cells, but this will be onto the media that we create custom for the application. Power delivery or power transmission. Because we will have a transmitting antenna and a receiving antenna, both as the same, those are called rectennas. The technique that's used is called retrodirective, which is actually just like if you could understand time reversal, almost like a sonar. Well, electronically you can hone in and do that at many flashes per second, and you can hone in and localize exactly where you're looking. This is a way that GPS and when you do reconnaissance stuff, how you can focus in on exactly what you're looking for. So sonar uses time reversal. Microwave transmission and wireless energy transmission. Of course, the Wharton Tower, this is Tesla's dream come true. There's many studies, and I'm just going to point out over to the right-hand side that I've illuminated. We have the 2.45 to 5.8 gigahertz showing the measured efficiency in the up 90%. And this is making Tesla's dream come true with our rectennas and retrodirective energy transmission. This is the fun stuff. How would you use Insta-Grid? What kind of products could you have? If you look at the lower right-hand side, you'll see that there's a solar cell hanging off the back of the boat because their top doesn't have solar cells on it. Our Insta-Grid will be made so you can actually have that top is your solar cell and an antenna. You want a cool tent or an RV of any sort? This is not our product, but this is a product that's available. They have solar cells on it, and then they have LED lights. And you can see that you can do his laptop in it. We can make the entire material without all this wood and such. It would be our material, and it would be able to transmit. So you could transmit up to a cell. You could actually get TV, dish TV, wherever you are in the world, and you could power it. So you could illuminate, power, and be connected to the website anywhere in the world. So a little bit more than what we see here. How could you personally use it? Clothing that can transmit back and forth. Say you're running out of energy and another guy has energy, you could actually plug in your cell phone to the clothing you're wearing and you could say transmit. We will actually have this material with IDs built into them so you can actually attach to the Internet of Things, of everything, and then you could actually transmit energy to your friend and they could power up whatever they have, whether it's a phone, a laptop, or what have you. So transmitting with electronic clothing. We will actually embed some LEDs and electronic fabric that's illuminating and maybe even some that might vibrate. So think about that. An important thing that we all feel when there's very bad storms is we have no signal. We could actually wrap our Insta-Grid around the solar cell tower. It would be the tower. Not only would it create its own and self-energizing power itself, because right now they actually hook up to the electrical power grid, and so if a grid goes down, the solar cells in that area go down. With our material, it'll never go down. It always has its own power, and it can transmit itself, so you increase the capability dramatically. This, what you are seeing here, is NASA's first satellite. It's called the Echo. This one here is the second Echo. It was launched in 1960. They did Echo 1. This is Echo 2. It's 41 meters in diameter. Conceptually, Dr. Hyland has developed our material to do an Echo type of space satellite at 100 meters, so a little bit more than 2.5 times its diameter. If you look down on the bottom of that satellite, you'll see the car with the people next to it. Anyway, that's how huge it is. But ours would be 2.5 times the size of it, which means lots of energy, lots of communication. We can do a lot with it. The Power Star, as I had said, Dr. Hyland, by harvesting the energy from the sun and retrodirectively transmitting down to Earth, like on top of our grid system itself. We can have our own material, the same material down on Earth, protecting the grid system and transmitting it right to it. So we could power up the Earth or anywhere else in the world. And you can see the patent over to the right-hand corner. Ultimately, to summarize, we can take the Insta-Grid, the structurally configured microwave fabric. We can make consumer goods. From that, we will evolve it. We will put a sew-in electro current fibers and then make Faraday cages into the structure material itself. And it will be a self-powered Faraday cage, which we will tarp over the grid system, providing us a EMP, electromagnetic pulse, and an upper atmospheric nuclear attack and a solar flare attack. This would protect our grid system for all of our country. Very important. Since it's bulletproof, EMP hardened or nuclear hardened, now we can actually wrap some of this material around a fuel truck at the military, which is now it becomes more bullet resistant and EMP resistant, so it's no longer a moving bomb. Then we will evolve that because it's got to be an outer atmosphere for a satellite, so that's why you want to have the solar flare protection, because you have no atmospheres out there. Now we have our power star satellites, which can beam energy to Earth. We're only going after 10% of the entire Earth for the growth of society and for evolving different nations, like third worlds becoming a second world or a second coming a first world. We can actually help produce the energy without making nuclear plants or digging up more oil. So we can help with the growth of society. Since we can do that and retrodirectively transmit the energy down to Earth onto our grid system, now we can actually make our power star into a more missile defense system. We can actually tweak the frequency and vaporize on a 20 metric ton asteroid coming at us. We can vaporize that. We could actually do a much larger one. Our first launch would be 3 of them, so 60 metric tons, no problem. Vaporize a extinction life event asteroid. We could vaporize it in space before it actually hits Earth, or if some radical terrorist wants to set up a nuclear bomb and send it towards us, we could actually vaporize and blow up that missile anywhere on the Earth at the speed of light. Now, since we can do that, we can also transmit energy to a space traveling vehicle. If you want to get to Mars with Boeing's new electromagnetic propulsion system, we can transmit energy to that propulsion system instead of just their collection of light. We send them energy right to it. Now they can really crank and get to Mars super fast. Instead of 6 months, you can do it in less than 6 days. Heck, 6 hours, but stopping at Mars is almost the impossible thing. So whatever you get there, you still have to be able to stop. So that's the trick. Anyway, you can see much more product evolution and capabilities for all of mankind.